Have you ever looked up at the night sky and felt tiny? It's a feeling that's hard to avoid when you see the endless sea of stars stretching above you, each one a sun, possibly with its own planets and mysteries. The universe is so vast, it can make even the tallest mountain or the biggest city seem like a speck of dust. The universe is so vast that our usual rulers, kilometers or miles, just don't cut it. Even the fastest jet or the longest road trip can't begin to cover the distances between stars and galaxies. Imagine measuring the distance to another star with a school ruler. Impossible. You'd need trillions of rulers, and you'd still never reach the end. So what do scientists use? Light itself. It's the only thing fast enough to cross the unimaginable distances of space. Light is the fastest thing in the universe. It travels at nearly 300,000 kilometers per second, fast enough to circle the Earth more than 7 times in just 1 second. When you flip a switch, the light seems instant, but it's actually made of tiny particles called photons. These photons are the messengers of the universe, racing from one place to another. These photons travel at incredible speeds, carrying information across space. Every time you look at the stars, you're actually catching photons that have traveled for years, decades, or even millions of years to reach your eyes. Everything we see, from the moon to distant galaxies, reaches us because of these photons. They bring us news from the farthest corners of the cosmos. It's like the universe is sending us postcards in the form of light. Each photon is a tiny message, telling us about where it came from and what it's seen along the way. By studying these postcards, we learn about the cosmos. Astronomers decode the light to discover the age, distance, and makeup of stars and galaxies. The speed of light is constant everywhere, making it the perfect universal ruler. No matter where you are in the universe, light always travels at the same speed. Instead of getting lost in huge numbers, we use the journey of a photon to map the universe. We measure distances in light years, the distance light travels in 1 year. This simple idea helps us understand our place in the cosmos. It connects us to the stars and galaxies, no matter how far away they are. Good science is all about finding the right tools for big questions. And sometimes the tiniest rulers, like photons, are the ones that help us measure the biggest mysteries of all. So how fast is light really? It's a question that has fascinated scientists and dreamers alike for centuries. Light is the fastest thing in the universe, and its speed is truly mind-boggling. Light travels at about 300,000 kilometers per second, an almost unimaginable velocity. That's fast enough to circle the entire planet more than 7 times in just a single second. If you could move at light speed, you'd see the world blur past in an instant. But there's a catch. Nothing with mass can ever go faster than this. That's Einstein's rule, a fundamental law of physics that shapes our universe. Because light isn't instant, every time we look into space, we're actually peering back in time. The farther we look, the older the light we see. For example, light from the moon takes about 1.3 seconds to reach our eyes here on Earth. And from the sun, it takes roughly 8 minutes for its rays to arrive. That means if the sun suddenly disappeared, we wouldn't notice anything had changed for over 8 minutes. A truly strange thought. For Mars, depending on where it is in its orbit, light can take anywhere from 4 to 20 minutes to travel between our 2 planets. This delay makes real-time communication with spacecraft a huge challenge for NASA, ISRO, and other space agencies. Every command and response is slowed by the vast distances. The speed of light isn't just a fun fact. It's a fundamental limit that shapes how we explore, communicate, and even understand the universe itself. Now, what's a light year? It's not a measure of time. It's actually a measure of distance, and it's one of the most fascinating concepts in astronomy. When we talk about light years, we're talking about the incredible journey that light takes as it moves through the vast emptiness of space. A light year is the distance that light, the fastest thing in the universe, travels in a single year, about 9.5 trillion kilometers, or nearly 6 trillion miles. That's a number so huge, it's almost impossible to imagine. Space is so unimaginably big that we need this enormous unit just to make sense of the distances between stars and galaxies. Without it, the numbers would be overwhelming. For example, the closest star to us, Proxima Centauri, is 4.2 light-years away. That means its light takes over 4 years to reach us, covering more than 40 trillion kilometers in that time. Instead of saying over 40 trillion kilometers, astronomers just say 4.2 light-years. It's a much simpler, more elegant way to talk about these mind-boggling distances. And here's something amazing. When we look up at the stars, we're not seeing them as they are right now. but as they were years, decades, or even millennia ago. Take Polaris, the North Star. It's 433 light-years away, so the light we see tonight actually left Polaris when Shah Jahan, the builder of the Taj Mahal, was born in the 16th century. And the Andromeda Galaxy? Its light began its journey toward us 2.5 million years ago, long before humans even existed as a species. So when we gaze into the night sky, we're actually looking at ancient snapshots of the universe, preserved in beams of light that have traveled across unimaginable distances and times. Light years connect us to cosmic history, letting us witness events that happened long before our own time. The farther we look into space, the deeper into the past we see, unlocking secrets of the universe's history with every observation. In a way, stargazing is like using a time machine. Each glance through a telescope is a journey back through time, connecting us to the wonders of the cosmos. Light years are too big for our solar system, so astronomers use the astronomical unit, or AU. 1 AU is the average distance from Earth to the Sun, about 150 million kilometers. Earth is 1 AU from the Sun. Mars is about 1.5 AU, Jupiter 5.2 AU, Neptune 30 AU. This makes mapping our solar system much easier. The AU is the workhorse for planning missions and understanding planetary distances. Engineers use AU to calculate spacecraft routes and fuel. It turns huge numbers into manageable ones. Light years help us look out. AUs help us navigate our own backyard. Both are essential for exploring space. Understanding light years and AUs helps us make sense of the universe. AUs are perfect for our solar system. Light years for the vast distances between stars. Light years remind us that looking at stars is looking into the past. These units let scientists map the cosmos, plan missions, and aim telescopes. They turn impossible distances into understandable numbers. Next time you look at the stars, remember, some of that light is older than human civilization. The light from our galaxy center takes 25,000 years to reach us. We're seeing the Stone Age. Space is an ancient storybook, and we're just learning to read it.